Not allowed to smile. Put on my best smile.
Okay. All right. Hello, world.
Hi.
We're back.
Yeah.
We're back for a second session. Cardboard electronics, as to pair with our Inventing with Cardboard previous Google Hangout. So we've gotten a lot of positive feedback, actually, about our prototype of our talk-through sessions.
We're really good at like prototyping in many ways. Apparently, also here testing together with you, and you seem to be on the same page there. So accepting all the little mini failures through and then prototyping this. It's cool.
Definitely. Yeah. So like last time, as a recap, is we created these little cardboard puppets, things like cats and dogs, foxes, and other kinds of animals.
Yeah.
Prehistoric, Jurassic.
So we have them remote controlled by straw. So they were very simple mechanisms, but cool nonetheless. We also have this a bit more advanced, very manual, mechanical creatures or puppets. And today we're going to go through how to add movement to them and talk through how we do that and how we design it. So hopefully you can get some information and make it easier for you to do the same.
Yes. So last time we focused on the inventor kit and the sample of the cardboard kit. And today we're going to be adding the coding and robotics kit to your cardboard creations. So Eric, would you like to walk us through the next steps of how to add electronics for your creations to life?
I tried to break down my process because these are, I kind of like the prototype of talk through things. So my process of going through and designing these moving things is basically this. So we can talk it through here, see from the top.
So go to the inventor's desk.
Actually write with my really poor writing skills. So the first step I do is figure out the axis of rotation, because we have rotational servos. Then we have to kind of figure out where should our robot move around what. So axis of rotation. So then we figured out that we need to make a decision on if we want to apply our movement from our servo direct or indirect, and I'll go through this, what this means. But this is a decision we have to make. And basically this means that you just connect the motor, you connect whatever is going to move immediately to the motor, and this is through a linkage. And it might seem like this is easier, but in many ways this is actually the easiest preferred option. But I'll go through that so you can see why that is. And then you need to figure out, depending on what you chose here, you need to figure out my motor or the motor position. Motor position. And once you figure that out, you put the motor in the position you chose by making any kind of connections. We'll show that too. Once you've done that, you turn on your motor to your movement. Today we're going to use the standard program in the beginning to not keep it overly complex. So when I turn it up like this, it's going to do the little movement.
So this is the pre-program that comes with the Corkbot when you first open the coding and robotics kits.
Yeah. So we're going to base our robots today on this, and then I'll show some segues later where we actually reprogram it. But so it's a very important step to actually connect and motor. Oh, I mock up. I actually messed up myself here. So actually, this is the step first when you put your motor on and connect it to some stuff. But you leave one last piece unconnected. I'll show that also. Then you power up, like I did now, and observe to see if the movement looks okay. Because otherwise, you might have your servo arm in a weird place, and then everything is just going to be chaos, which is fun also. But today, I wanted to show my way of constructing. So let's do that. And then you power up and observe. And then last step is connect everything once you see that, OK, it's moving in the right place. And this is where you would normally reprogram if your movement is super strange compared to your mechanical things in the puppet, you have to recode there or reprogram it. So then last thing, connect the last piece and then power it up. And then hopefully, if all these steps have gone through, you will have a moving object. So should we start with
yes,
something?
let's do it.
I wonder, this is one of the places where it would be fun to have people choose which one we should animate first. But today we chose your newly wonderfully designed fox. So hopefully people agree. Do you agree? Should we do it? Should we get him up and animate him?
Let's animate him.
So then we have the first step here. Axis of rotation. Where is the axis of rotation for this movement? It is already done because we made our mechanical puppet. So once you've made your mechanical puppet, you have your axis of rotation already. It's going to be down here. We want this tail to move automatically.
Move with the remote control.
I'm moving it now with my straw remote, which is almost as good as the motor. So, and then we have to choose if we want to connect it direct or indirect. So because we want to go through all these things, maybe we should just start with a direct connection to the tail, which is actually where I sometimes use a bit of tape because it's easier. So I'll show that today. That's why we enforced this. We strengthened this a little bit with a piece of tape also. So let's go through putting up our direct mount. So we have this little motor that one is supposed to move the tail. So how do we connect it? The first thing we do is actually counterintuitive. We disconnect. So I take these away, and then we have our little creature, the back of it here. So what I like to do with these servo mounts that really make everything easier, we want a straw somewhere here that we can connect our servo mount to. So I take my little straw here, and I've actually pre-made some holes here. This is in this stage you would make holes in your the stand for the creature and push.
What does this beam do? Does it help a lot with the?
It's basically only to be able to hold your motor somewhere on here. So this gives us a place to connect our motor mount.
To snap the snap the motor
mount. So
what
we see here now is like, whoop. And so now we can actually double check what I did now was trying to find an axis of rotation. Now we're slightly off, you see, because getting it exactly there, then you have to do everything. Really, you have to kind of, you can push it a little bit further back, maybe, so we are closer. Now we're offset with maybe a centimeter or something. That's okay. For me, in a fox, it's okay. If it has to walk really straight, it might be tricky. And then we, in this case, because we're direct connection and there's actually nothing it can crash with, we can let's just put it on there.
Okay.
In this case, the easiest way is to just put a piece of tape on this Strawbees, then you can actually slide it off and on. So we have it there. Because then we don't add anything that can get caught into the cardboard. So this is one of the few areas where we made it modular, so we can disconnect our tail and we can connect it again like this.
So we don't have it cause friction, so it wouldn't be like this.
You could connect it through here to the cardboard, but then you have to figure out how to make them not crash with each other, which is also not too hard. So now we chose the motor position because it was close to here. We connected it immediately. We actually skipped the power and observe because we see that it's not going to really crash with anything. But we could, that would mean that we actually leave it like this and power it up. So now we power up and observe. And it looks like this tail movement is pretty safe. Doesn't it?
I would think so.
Yeah. So then we can turn it off again and we go to the last step, where if it wouldn't be if we would be moving really strange or weirdly or downwards, we would either shift the motor mount, the servo connector, the little arm, and put it the other way, or we reprogram it in the computer. But now we can just go to the last step, connect our little moving part, and then now we don't look at the nice side, but we look at the mechanical part, which is for some really nice. Oh, I'm closing a circuit there, so there we have our direct movement. So if you're pleased with the exact this layout, you can just stop there. So there we have it. And when you let it go, inertia will.
It's a very excited, happy fox.
Yeah. So actually, if we look from the front now, can we shift? I don't know. Should we shift to the front camera?
Mm-hmm.
He's a very happy fox. There we have him. Just very, very happy. So I think this is an example of the direct mount. Nothing is advanced. It's very simple. The problem is maybe that it's a little bit trickier to actually change where you want the tail to move. So then you have to go into code, maybe slow it down, maybe move it to different end values on your program. But I'll show how to modify this to the second solution, which is the indirect movement.
Okay.
So we can test that too. And then actually, that would be less of a transformation from the original construction than we did now, because now we disconnected everything. But if you choose the indirect version, the big advantage would be that we take our little tail here, take off this. This is good with a paper tape. So that is really easy to.
Something like masking tape is the perfect material.
Yeah, masking tape is very nice. If you're going to use tape, use it wisely. Use a little of it, and don't make a big mess so you can't use it modularly again. And then we want to connect our little fox tail here. So in this case, we actually made for animation, we made a slot with the
punch tool?
Yeah.
That's the flat end, right?
Yeah. And this, you could see that in the previous video too, how we use that. So then we can connect this to the cardboard and secure it on the front. And this is how we made our remote, which basically is our little linkage. So now we are back to square one that we were before, except we actually added this tool. But then we can go back to this. Okay, well, now we chose the indirect. It might sound a little bit fancy and stuff, but I just wanted to have some kind of name for it. But this could be same direct motion or linkage. And as a mechanical engineer, I love linkages and different things that happen. So I prefer that one. Might be that.
We'll have to make an upcoming video just on linkages.
Yeah. So then we can start here. And then we have the second thing, figure out a good motor position. And because today we want to be really resource efficient, we don't want to cut the straw. Then we need the motor to be somewhere to reach this place. Okay. So then we want the motor to maybe be somewhere on the other side of this structure. So we push this through here. And as you see now, I'm really just connecting it. Maybe I would like to get it to stop here. And then we can show a little bit of a secret trick that I usually use is a friction lock. Now you get behind the scenes. And then I can actually secure it like that without connecting it too much. And then we take our little servo once again. So we figure out the motor position. That's the third step. Maybe somewhere here would be good. Does the tail reach? Maybe we want to. So usually when I build these, I want it to be very close to the cardboard. So I actually flip the motor this way instead of that way.
Why is that?
So I get it closer to the linkage here. So it actually does. If up here, it's a little bit outside of the. It's lifted up from the cardboard. You can't really see it.
Yeah, can we show that?
I don't know. Can we?
I think we can try.
This is fun. This is all an experiment. So if you don't follow, please ask us to make a clearer version of that particular move. So what I'm saying was you can choose to have the servo mounted. It's actually trickier with one hand. To have it mounted this way. And I can see from the top, you see that the arm is way out. It's almost 2 centimeters out. And if I switch it the other way, put it here, and it's flush to the cardboard surface. You see there, or flush and flush. This pretty flush, which can be good because this arm is also flush to the cardboard. You see there, so that's pretty good. And then we just have to connect these to each other. And because we have our basic Strawbees skills done. We can connect it to.
In the last video, we definitely accomplished a lot of talk about joints, the many versions of joints.
So actually now we follow this little rule here again. So we connect, now we connect everything, mocked it up manually, so we can actually see, okay, this is the movement. This would probably work. So we mock it up with our hands before we do anything. And then, so we don't break anything, the only thing that happens is basically the straw bends or it pops off, the servo mount pops off. That's how we designed it, so you should be able to do it. But it's still kind of cool to go through this sequence. So then we power up and observe the movement. It shouldn't have changed since the last time, but you never know.
Yeah.
Might have snuck in some code. This looks okay. So the mock-up would be this movement. It's pretty neat. Then we connect this thing here, and it might have looked like this was more steps than the previous, but actually it's really, once we had this straw, it was really fast. So now we connect our little fox, and we have the movement going. And it's actually because of the beams difference. You can do lots of experiments there. Let's see what the movement looks like. It's pretty similar, but one of the interesting things with having this linkage is that we can go back here. So if we're not pleased with the movement, this Strawbee is stuck in a little slot, the one that I'm connecting Strawbee here. And this one you can slide, so then we can actually change how the tail, where the tail is connected to this this beam. So now we've changed the movement. So you see now it's going to bang the table with its tail, which is much more fox-like. So you still see the top here. Doesn't that? Oh, now actually you see some of the linkage. That would be something I would redesign later, maybe. If I'm not pleased with seeing the linkage, you could change that a little bit. Or
still part of the mock-up process.
Yeah, it's prototyping and getting the movement going. So let's look at him from the front. And that changes it a little bit more. Yeah, here's Foxy. And then you can make him move faster with the standard program.
How are we doing that?
With the little touch pads in the front here, in the top, the horn.
So on the pre-programmed settings of the corkbot, you can actually just pinch the horn, and you can switch, like invert the program. Yeah,
which is, or like it actually just increases the wavelength of this movement. So what could be really fun here is actually using this in a story for your fox. So for example, you can make something that conducts electricity. So when you touch the nose, it waves the tail.
Like this, for example.
Yeah, and then
even cutting a hole, so you just touch the nose, pinch the nose.
So that was our first little animation, and I don't know where we are on time there, but that was hopefully pretty clear. What did you think? Did you follow?
I think so.
I don't know, and this is also something, the steps that I put down, they're also a prototype from my end. So let's see if it works on our second little robot. So we're going to reuse the same brain, because that's one of the, if we switch shift again, that's one of the features of the QuirkBot is that you can actually have a couple of these projects, low piece count in terms of Strawbees and low piece count in straws. And you use your cardboard, which is very readily available almost everywhere. And then you can have a couple of these little puppets animatable. So you can just snap in your structure. So this is from the last little session, our remote controlled cat, fox, dog. But I think we can, let's agree it's a cat today.
Definitely.
Yeah. I was a bit of a, I was like playing around. So now we have to figure out the axis of rotation. Once again, we've already done it. It's around here, it will rotate. Okay, so we're down with that. Then we need to figure out, do we want to make it direct or indirect? Because we've already seen, we have to make a couple of holes here to make it direct or figure out a way of getting the motor there. It's not impossible, but today let's go to for the indirect, because it's more standardized. And we can also show another way of connecting the motor mount. So I will choose a motor position that is somewhere down here. And I also, because I have the indirect thing, I chose this is where I want the motor position. And then we can look at the linkages here. We need a slightly shorter arm up there. So actually, I had a cutoff lying around here. Maybe we can use that. We can just, because this is something you can experiment with a lot. It's really fun to not think this through too much, but just test it. Actually, I want a little bit longer just to make them pretty similar. So I just eyeballed and cut pretty similar. So I changed the angle here of this little thing to make my linkage. So there we have that. And then we need a little swivel connection. This one we made in the last video too. We go about
a rotating joint.
Yeah, a rotating joint. So now we can see it's connected to the head. Boom, boom, boom. And these are all mock-ups. So now we want to connect this before we make the last little linkage. So now we're going through linkage design, even though we haven't introduced linkages yet, but obviously these are very simple linkages. So we want to make holes so we can connect our servo mount. Because servo mount, if you look at it, you see it has little knobs, little protruding things here. So then you can actually connect to Strawbee. If you look from the side, you see I've connected a Strawbee there. I connect another one here. So now we need to make corresponding holes. So I used just a pen to mark the 2 points where I wanted to have my servo. And then we make our holes. And this is where it's good, because now we have this wonderful fox cat. I'm just kidding. So we want to make this hole. Then it's good to use this. We don't fold your very nice design.
And we're using the rounded.
Yeah, rounded one.
The rounded punch into the holder. Prevents less wrinkles.
Yeah, so you get it to look a bit nicer. So there we have it, our 2 holes. We take our little servo and we chuck them through the cardboard and secure them on the other side. So now we have 2 little points. So this will be visible on the front. So that's also a reason that it can be good to attach to the base or something that's behind. But in this case, we wanted to show the most direct approach, and it doesn't always affect too much. So we're choosing this one now just to show a variety of solutions, so we don't just solve it the same way all the time. Okay, so now we have our little. You can also have these washers maybe, but for now, this is what is out in the world.
Oh, it's like a zipper.
Yeah, and now I see that I have this one on the strange way. So I just change this because it would hit, it have some interference there. Okay, so now we go through our, this is basically the connect and mock-up. We can see what happens here. We have a movement, center something like this. And now we actually show a design phase here. So we can actually test the power it up now before we cut the straw, because now we know approximately, we have seen this before because we're using the same, but we're repeating it just to show the basic problem solving. So now we have this movement and it looks really good. It's not going to interfere anywhere. It's not going to hit this. So we don't have to do any changes. Then we just stop it at a good position. And actually without cutting, we can connect it. Then maybe the head is going to be a little bit offset. So sometimes you don't have to, we can actually just connect it. This is how easy we wanted it to be. So you can actually just test it and see if you're pleased with the movement or not. So now it's going to be leaning a little bit to the side. It has a very small movement because of the friction. It's better when you have him standing up like this and move more. He's looking to the side, so maybe we could have like a switch. This also turns into a little bit of storytelling. So when I see this, I immediately see that he's reacting on something coming from this direction. So for example, it would be perfect to have like a little switch, a little bowl of food or something where you put something heavy. You have a sensor that sees that you got something and then it looks that way. So sometimes this is how I would like react and start making a story of something that I wanted. If for example, you wanted him to move around the center, you would be a little bit, oh, this isn't doing what I wanted to do. But then you imagine what it's actually doing. It's looking at something over here.
It's also like an animation where it could be like moving something. It could knock something over to reveal something from behind, even just like only solely with cardboard.
But then we can also imagine that I really wanted it to be moving around the center. So then we go back here and we look at how it was moving. So we see, okay, where's the center? It's actually when the arm is here. And then we want to center the head. And this is where we would make our decision on cutting. Then we cut here when it's straight. And we always save these pieces because, as you saw before, I just used a straw cutoff, another part there. Now we connect it, and then we have our our centered head. Oh, now I'm showing it. Actually, it would be better if we could switch to the other view. It has some interference with this hole here. That's why
a little bit of friction on the
chin. So the smaller things you do, the more you have to think things through. It's actually trickier sometimes to make small objects because then you have less space. Ooh, this is the switch once again. It was got really excited when he got a bit of food there. So are you pleased with your movement here?
I love it.
Yeah. So he can stand here for a little while and just hang out with us. But you see, this is the interference. It's hooking on that one. And that's something I would change. For example, you could push a washer in between the head and the body from cardboard.
Sometimes putting a little bit of tape, like the clear plastic tape, which helps prevent friction, like with 2 pieces of cardboard, really helps as well.
So we can just leave him on for a little while there while we move to the next one. And
so I think we'll have time just for one more.
Yeah.
Like
and then we'll end with a big show. But I'll show this because this was from the last episode also. Remember him? And this is actually going to show. It had a tail remote for the ears.
So it's doing 2 animations.
Yeah, 2 animations at the same time. And there's once again a little linkage here. They're almost the same, but not quite. And it uses the same through cardboard connection, so it actually is connected to the ear. And this one has a movable connection, so we can actually change the ear position. But this one, axis of rotation, there are 2 axes of rotation. As you can see, there's 2 points here where it's moving around, boing, boing, boing. And then we just have to figure out direct or indirect. This is actually one of the slightly trickier ones, because now we're doing something that's in between. But so I will go for the slightly indirect approach. And this is actually one of the easiest objects to motorize, even though it doesn't really feel that way first. But I'll show why now, because we can just pick any of these points. We see that maybe the axis of rotation we're going to animate is, if you look at these points here, these 2, you see that there's an angle changing, like the angle between these 2 straws is changing. You see that? Even though it's moving, this angle is flat, or like very pointy, and then big. And that is exactly what the servo does. So in this object, we can actually just switch this straw out for this one. So, or actually we can do, I'll just disconnect this completely, take this one out. So you see, this is actually a really, really fast change. We take these off so I just took away some stuff from the from the dog and then connected it. And in this case, we could do the first mock-up, but now we've done this mock-up so many times that we know how it's going to move. So we can make a pretty good, we have a pretty good idea of what's going to happen. But it's always good when you do it the first time to actually check the movement. Now we're checking the movement together, and let's see what happens. So there we have the movement. It's already up and running. We can connect our cork bot somewhere on the in the animal. If we look from the front, you see we have a strange animation. I And this is maybe, so do we want to make any changes? Do we want the tail maybe to be more happy?
Maybe the tail wagging a little higher to show true, like full-on excitement.
So we stop, and then we figure out, okay, where the tail is connected like this, we can actually change the tail position. We can also change the ear position if we would like to. But should we just test it like this?
What if the ear goes over the eye?
That's cool.
We should try that.
So let's try that. And then we show what I'm doing here. So if you remember, if you look back at the previous episode, we saw we had a folded Strawbee like this. And I secured this part to the cardboard ear. And then it's going through here. So this is, you can actually change the ear position here very easily. So let's go and turn it. And you see, when I'm turning this, I'm not turning the mechanism. I'm only turning the ear. So let's see what happens. I just tested it, and then does it have it over the eyes? I didn't check. Yeah,
it does.
So let's see. Where do you think? Do you remember where we stopped?
Let's find out.
It's just moving across the eyes. You want to change that again?
I think we should change it a little bit more.
Go up a little bit.
Yeah, just a little bit higher down, covering the eye.
So we do which movement? It's going from. Let's see. It's going from this end to that end. So I want to stop it here. What I'm doing now is thinking. So this is the highest position of the eye. So we swivel it like this, and there we are. Let's see. Ta-da! I don't know.
That's closer.
It's closer.
It's like closer.
You see, it's a lot of
fine-tuning and
fine-tuning and going over and over again. And then maybe also, in this case, it would be great to go into code. Because maybe you wanted to move a bit farther. Maybe you wanted to react to something. And now it's super happy like that. I like the ears when they're a little bit back. So I'm going to just do one last change again here.
I also want to try modifying it so the cork ball is actually like easier to see, so it's not just hanging off.
Go ahead.
Yeah.
You can show the modification.
So let's show on the webcam. So I think with the cork bot, since right now, lately we've been having it hang off, I think what I want to do is I want to create like a collar for it. So it's kind of hanging off like this. So if I just use the punch, just secure a small spot for it, like just stick it like that. Let's give it a little bit more loose.
You can test it.
Something like this.
And then you connect it on the back, so it doesn't just.
Yes, we need to put a small Strawbee washer. We'll use actual washer.
Yeah. And this is how you should go about prototyping, mocking up, testing. Now it has a little corkboard collar.
Let's try it.
Here we are. And obviously now we're just running the basic program. There's nothing advanced in there. It's just, you just play around with what you have in the beginning. So you're doing physical programming by changing the linkages, changing the angles between the straws. So if you have come to this position, it's very easy to change. What happens if I take a longer straw here? Just don't think it through too far, just test it. As long as you can do the mock-up before CC, you won't break anything. You can just go about testing it. And that is something that it's really good to do that, because the more times you do it, the more your brain actually starts seeing almost what's going to happen beforehand. And then you realize that, my brain is starting to actually figure this stuff out. But in the beginning, you just have to play with it. And so should we show the last little advanced, just a little demo?
And there's a small demo we want to show. A few times we've been asked, is QuarkBot compatible with Scratch? Can we actually use QuarkBot with Scratch? And the answer is yes, definitely can. So for our last demo, we're going to focus on showing you kind of how to build the program, or use the program that's already pre-programmed, and then show you a really basic Scratch program that we have.
So if you show that, I will actually attach some motors to the back of this. So you can show the code, and I'll in the background.
Yes. Or
maybe you can just shift to that. I'll be fast here, because this was supposed to show this a little bit, but just.
So this is slightly more advanced linkage building. But this is like kind of more of an inspirational project.
Yeah, so
just
we just
to see
want to
how
show
advanced and just to show some experience linkages.
We can very briefly go through. So I just made this linkage. It looks like it's super advanced, but we're going to post a downloadable thing. It's actually a really simple linkage once you look at it a little bit closer. It has 2 movements. You can open and close the jaw, and opens the jaw when you operate that. So I will connect my motor here. So I have to figure out the axis of rotation first, and there's a couple of them here. So this is slightly trickier, but I just used 2 straws to connect this here, and then I have a good position. So my axis of rotation will be here for the animation. And now we have it animated. And the reason we introduced, is this my, there we are. Oh, yeah, it's opening its jaw and closing it really fast. So we can just see here what it's doing. Wow. Yeah, super dangerous dinosaur. So we won't go into the code too far, but what this does is actually, if you connect it to the computer, it will send a key press. And as some of you might know, if you've tried Scratch, you can see that key press is a way of interacting in Scratch. So we can go into Scratch here.
So I'll go ahead and share our screen just so you can kind of see.
There we have it. And then I can do the code here. So what we want to do is what I'm sending now from my QWERTY is key A. So when A key is pressed, we want to launch a sound. So we actually choose the play sound. So this is a very simple connection between the systems. And I've previously uploaded a sound that is a roar. So when we press key A, this laptop will play the sound roar. So I can actually test. Now we have to turn on the sound. So we test it before we connect the robot. Sounds very dinosaur-y, doesn't it? And then we can actually shift to the front view here. So much technology, we're testing it. This is really exciting. Let's see. Oh, there we are. Hi again. So this USB cable is connected to the computer, which turns the QWERTY into a little key.
Like an external keyboard.
Yeah, external keyboard. So when I connect this and I run the program in my animation.
What are you connecting it to?
To the QWERTY's little. Here you see there's a USB. That's where you charge it, feed it code, and you can also make it a keyboard through that hole. So I turn the QWERTY on, and then we shift to the Scratch. Oh, that's the problem. So now we actually, because the same computer is doing the sound, and I'll have to use my laptop here. Luckily, we have a spare one here. So let's show it. So I take the USB cable here, and I connect it to my laptop, turn it into a keyboard on my laptop. Hopefully it connected there. See, I'm just going to test because I have the same program on that one. I didn't hear any bitty bump. No, okay, now we're going to hear the bitty bump. The sound of something connecting to Windows. Yeah, there we have it. And now let's see what happens. First time, Scratch usually doesn't catch the key press, so we'll wait. Okay, now let's see. So there we had it. A dinosaur animation and sound. So that's where you can end up when you started doing your puppets and playing around a little bit and getting fluent in both our coding system and Scratch, and using technology as a tool for you to just have fun with.
So you can use our coding platform as well as combine Scratch. Easily partner together.
Yeah. So T-Rex wants to say bye.
Thank you. As always, thank you everyone for watching us. We really appreciate your feedback. Please let us know if there's any wishes, requests. We're going to be trying to push more of this content online, more of this inspirational content, as well as more instructional videos to be coming soon this fall. And
Yeah.
Eric, is there anything else you'd like to add?
Now, thank you for taking the time and hope you had fun. And I hope to see some really cool cardboard puppets out there.
Definitely, definitely. Well, thank you all. And also, on the last video, we definitely mentioned about the marble run. So we're going to be doing a future video about that coming soon. All right. Well, take care, everyone. Thank you again.
Bye. Bye.